So today we're going to set up the dehydration of the 2-methyl-1-phenyl cyclohexanol. And so I have my purified alcohols. The solvent is xylenes, which is a mixture of ortho, meta, and para-xylenes. So it has a boiling range about 136 to 140. And we're going to be heating our sand bath up to about 150. So we'll have a good reflux. So we need a stirring hot plate. And a metal bath. That way we'll fill about a third full with sand. So we'll be able to sink our flask in there nicely. And we'll want that over fairly close to the sink, so our condenser hoses can reach easily. Put that on the other side of the little brace there. And as usual, we'll set this up alongside so it can go down nicely. So that can turn on. We're going to be running this reaction in a 50 milliliter recovery flask with the condenser on top and a football-shaped stir bar. And we're going to be collecting aliquots of this at a bunch of different time points. So I'm going to fill my row A here. So we're going to collect at time equals 0 before we add the para-toluenesulfonic acid monohydrate. That'll be lot number A, and then we'll have 1 minute, 3 minute, 5 minute, 10 minute, 15 minute, 20 minute, 25 minute, 30 minute, and then we'll go 15 minutes, 45, 60, 75, 90, 105, and 120. So we're going to follow this over a 2-hour period, and we'll have A, B, C, D, E, F, G, H, I, J, K, L, M, N, and O for our lot number. And I'm going to be on page, I think 54 of my notebook. So these are going to be 54A. So that's A1 is 54A, and then we'll go all the way around there up to 54O. In each of those test tubes, we're going to be measuring 50 milligrams of potassium carbonate. I'll get a little micro spatula out for measuring that. And I'm not going to measure it each time exactly. I'm just going to measure once carefully. And what I usually use is one of these 25 ml Erlenmeyers so I can keep that upright in the balance. And this is going to go into one of these 50 milliliter holders so I can add my liquid directly. I need a pipette for that. Just going to grab a couple. I'll probably need another one at some point. Those can sit in the test tubes. And I will be clamping the flask and not clamping the condenser so that I can take the condenser off every time and reach in with a pipette. So I'll put a little bit of water in here. And I'll get my condenser set up. I want the longer one to be, well, they're about the same length, so it doesn't matter. I say I usually want the longer one to be the exit tube. Get those on nice and tight so they don't leak. And then, as usual, goes in the bottom. And comes out the top. Got a little weight. I'll hook that over there. So that can just hang there until I'm ready for it. I'm going to need this sand bath up at a temperature of about 150, so I'm going to turn this on, and probably a setting of about 250 will get me a constant sand bath temperature, maybe somewhere a little higher than 250. Takes quite a bit. This is not an accurate reading. And the best way to keep track of that thermometer will be to actually just put the thermometer through the side of the clamp. So we'll start that heating. So while I'm doing my measuring out, I'm getting my sand bath up to temperature. So I'm going to take the potassium carbonate and my crude product and the test tube rack over to the balance. And we'll measure out. We'll grab that 50 milliliter flask. And we'll measure out our 0.64 grams of starting material. Tear that flask. We'll just measure that directly into the 50 milliliter round bottom. So I've got 0.67 grams, which is a little bit more than I wanted. Take a little bit of milk. And so we're pretty good here. We're at 0.641 grams. That's almost exact. That'll be good enough. I've got my starting material in there. I'll put this cap on here for now. Set those guys aside. And then I'm going to tear one of these test tubes. In the flask. I'm going to add about 50 milligrams of the anhydrous potassium carbonate, which is probably about one spatula full. See how close that is. Actually, that was 95 milligrams, so one spatula full is a little more than we need. Maybe half a spatula would be suitable. Or at least a skimpy spatula. Let's see how much that is. So that's 37 milligrams. And a little bit more. That's 65 milligrams now. Not actually critical, but I do want about 50 milligrams. I want it to be fairly close. Now we're at 57 milligrams. I'm going to call that good enough. And I'm not actually going to weigh 50 milligrams. I just know about how much solid that is. So I'm going to put about the same amount of solid into every other test tube. And I'll be close at least to where I want to be. I also need to measure out 250 milligrams or 0.25 grams of the para-toluenesulfonic acid monohydrate. So we'll bring that over, weigh that onto a teared piece of weighing paper so it's ready to go when we need it. Well, that's tearing. I can take these back. Stuff's awfully wet. I hope it still works. Looks like it's pulled up some more moisture from the air, so it's probably more than a monohydrate at this point. It's really sticky. Not top quality reagent here. So we're looking at 263, 0.263 grams of the para-toluenesulfonic acid monohydrate. Since it's just catalytic in this and we're adding a fair number of equivalents, I'm not that worried about the fact that it's a little wet. So we'll set that aside. Now we're up at about 120 so far. We'll need that to rise a little bit more. And we're doing this in 25 milliliters of xylenes. So we need to measure 25 milliliters of xylene into the graduated cylinder. Definitely going to be spilling. Trying to measure from a huge flask. So that's actually 26 milliliters, but that's fine. A little bit of excess solvent won't hurt. The concentration is not that important. We're not looking to measure a reaction rate. We're just looking to try to achieve equilibrium. So we'll set that in the back to evaporate. And then swirl this around to get that nicely dissolved. And looks good. And now we can clamp that. I'm not going to insert this into the sand bath until I'm ready to start the reaction. We'll get that clamped in place. And we can set our condenser up on top. Making sure that this does not come into contact with the hot plate. Let me move that a little bit further back. So I'm definitely going to want a clamp that I can safely handle that with once it gets hot. So we'll grab that from the drawer into the oven. That will allow me to move that around without burning myself. So we're waiting for this to come up to temperature. And we're going to want to keep it at a constant kind of 140 to 150. We can turn on the condenser water and get that flowing. At a nice flow rate. So that's ready to go. The reason I didn't discard this pipette right away is I want a GC mass spec sample of that 52B. I'm going to grab a GC mass spec vial. And I'm going to label it 52B. I'm actually going to make a dichloromethane solution of that.